Okay, so acids, bases, here we go. So pH. So we started yesterday with introducing a acid-base pair, and then that's what this was all about. So last night's worksheet was all about that. I posted the answers, go check them. And I want to start with this. So I posted this as well. Try this, hit pause. If you're really lost, just watch me do it. But I'd like you to try it if you kind of know what you're doing. And here are the answers. Okay, so notice, did I include, I think yours, I have the other dates. So you can see in 2019, we're right where we are now. Last year, we were actually very much ahead, which kind of got messed up because this was the day that we quit coming here. And then the AP decided to delete the last 2 units, which was a month and a half of what we covered. So we lost like 6 weeks of what we covered, not on the exam last year. This year, they said everything's on the test. So we're back to actually right where we need to be. And so I'm not too worried. All right, here are the answers. So the Arrhenius definition of an acid is a substance that increases the H plus or the H3O plus. Remember, those two things mean the same thing. It's not two different things. It's just H2O plus water gets you H3O plus. So this is called the hydronium ion. The Arrhenius definition of a base is something that increases the OH minus in a water solution. Notice they're both in water solutions. We're going to see that today. Predict the products of the following aqueous reaction. So meaning they're put in water. So if there's an acid added and you don't add water as a reactant, then we say we just get H plus and Cl minus. It's not really appropriate to put H3O plus there because then you can't balance the oxygens. If you do add water, though, that's why we get H3O plus and then Cl minus. One of the things you're going to see about these as well, and I mentioned it yesterday, is it's always a 1-to-1 ratio with these. If they have more than one hydrogen that they lose it one at a time. So it's always 1-to-1-to-1-to-1 ratio in these. So the stoichiometry, if we end up doing that, which we will, you can see is very simple. Now that we have equilibrium, so the first one did not because it was a strong acid. This is a weak base. So it's going to take the hydrogen from water and you get NH4 plus and OH minus, which is what's left over from water when you remove an H. Showed you yesterday, think of water as HOH or H plus and OH minus, and there's our 2 ions that we need. Here's another acid. This is an organic acid, although we just get H plus and C2H3O2 minus, the acetate ion. If we add it to water, the difference is you get H3O plus. Again, synonymous with each other. This is the one that you'll see me do. When you have a hydroxide base, you can't add it to water because then the balancing just doesn't work out. So you just get ions. A hydrogen atom is made up of a blank and an electron. This would be a proton and an electron and no neutrons, most common isotope. A hydrogen ion is formed when a hydrogen atom loses an electron. And then all that's left is the proton in the nucleus. So that's why they say it's a proton donor. So the Bronsted-Lowry definition of an acid is something that donates a proton, which is an H plus. The Bronsted-Lowry definition of a base is something that accepts the proton or the H plus. So one goes down by an H plus, one goes up. The CH3COOH carboxyl group is a weak acid. What is its conjugate base? With a carboxyl group, you lose the hydrogen from the carboxyl group, not those. Carboxyl, you're going to see a lot of them with this because they use a lot of organic acids with pH. Finish the 2 ways to write the autoionization of water. So we're going to spend a lot of time with this today. H2O plus H2O yields H3O plus and OH minus, where one water acts as an acid and one acts as a base. One loses its hydrogen and becomes OH minus. The other one gains it and becomes H3O plus. If you don't add 2 waters, just like with the acids, you could do that. You really do have to know both because this is the best way to do it. This is the way the College Board does it. Write the KW expression for each then. So when we do KW, remember you don't include pure water. So we're just going to have H3O plus and OH minus, both to the first power. If we write it with only one water, the only difference being H3O plus is called H plus. Consider the following equilibrium. HCN plus H2O is in equilibrium with H3O plus and CN minus. Identify the two conjugate acid base pairs. So HCN is an acid, and its conjugate base or its base pair is what's left over when you remove an H plus. Water then must be the base that's accepting the hydrogen, and it becomes H3O plus its conjugate acid, so acid-base pair. And whether you're going left or right or left, you could see they're the same acid-base pairs. If I'm going from right to left, if we look at it going in that direction, we would say that H3O plus is giving up a hydrogen to the HCN. So once again, it would be the acid, and CN minus would be, or not HCN, but CN minus would be the base. Draw a box around the more appropriate representation. So notice the Ka value for this is, I can't see, but it's times 10 to the minus something. It's not greater than 1, it's less than 1. So Ks are products over reactants. If we have something like this that is much less than 1, that means you have way more reactants than you do products. And so this would be a better representation of that, showing the two equations. I guess with the bold and the larger, meaning there's more of it. Now, which acid is weaker? Remember, there's two acids in this equation. HCN, we said, is an acid, and H3O plus is an acid. Well, weaker means less ionized. Less ionized. Stronger acids are 100% ionized. Weak acids are something less than 100%. And there's that varying range based on the K value. We're going to see it again today. Okay, so which acid's weaker then? Well, is the reaction favored going from left to right, or is it favored from going from right to left? Well, it's favored going left to right because there's more of this, the reactants, than there are the products. Again, a K value less than 1. So that would mean it's ionizing in the right to left direction more so than the left to right, which means HCN is not being ionized as much as H3O plus is. So H3O plus would be the stronger acid. Oh, I did the stronger. We were looking for the weaker, so the weaker acid would be HCN. Why? Less ionized. Less ionized. We know that because there's more reactants than there are products. So H3O plus is ionizing more than HCN is. What's the conjugate base of H2O? So conjugate base means we're taking away a hydrogen plus. Conjugate acid, we're adding a hydrogen plus. Conjugate base, adding a hydrogen. That means it's acting as an acid. And wait a minute, conjugate base. This would not be very appropriate because that means OH minus is acting as an acid, which OH minus is not. But if it were, then it would be O minus 2 because you can lose an H plus from that, but that's not going to happen. Conjugate acid of, so again, this one will though, because this can go in both ways. This is amphoteric, like water. So water can act as an acid or a base. So can this one, because it can lose the hydrogen and become CO3 minus 2. That would be its conjugate base, or it can gain a hydrogen and become H2CO3, the weak acid, carbonic acid. All right. So there we are. So that's the review of today. So I'm going to stop this video. I'm going to start the next one with what we need to learn today, which is the pH. Just so if you want to stop and start, you can, because I think that was a lot for one.